Now let's go through some notes for the AWS Certified AI Practitioner exam. So first we take a look at the capabilities of generative AI. So in text, generative AI produces human-like writing, from creative stories to technical documentation. For images, it creates, edits, and manipulates visuals, which opens possibilities in design and marketing. In audio, it generates speech, music, and sound effects. And finally, in coding, it assists with writing, debugging, and optimizing software. So it automates content creation, enhances creative processes, and provides personalized experiences at scale. And Gen AI models learn patterns and relationships from vast training data, which helps them create new content that reflects these learned structures. And this process differs from traditional AI, which focuses on analysis and prediction. Now let's take a look at some broad AI concepts we need to know. So first off, artificial intelligence, AI, is the overarching field of AI, which creates intelligent systems that perform human-like tasks, for example, Siri and Alexa. And then machine learning, or ML, is a subset of AI that uses statistical techniques for prediction based on patterns. An example of ML is spam filters that learn to identify and block unwanted emails. And then deep learning, DL, is a type of machine learning based on neural networks that are capable of learning complex patterns from large datasets. For example, facial recognition systems used in smartphones and social media are powered by deep learning. And then finally, generative AI is a subset of deep learning that creates new data based on learned patterns, often without retraining. For example, ChatGPT, Grok, DeepSeek, Claude, etc. So Gen AI has a lot of potential, but there are challenges to consider. So first is hallucinations. AI models can sometimes generate false or misleading information. And so to mitigate this, we need to implement fact-checking mechanisms and maintain human oversight. We also have intellectual property concerns. So there could be the use of copyrighted material in training datasets and the potential for AI-generated content to infringe on existing IP rights. And so we need to carefully curate training data and use content filtering systems. There's also data security and privacy. The vast amounts of data required for AI models create potential vulnerabilities for breaches and privacy violations. And so adhering to privacy regulations are crucial. We also take a look at bias and fairness. AI models can perpetuate or amplify existing societal biases. And to mitigate this, we need to perform regular audits of model outputs and provide diverse representation in training data. We also have interpretability, so the lack of transparency in how many AI models operate makes it difficult to understand their decision-making processes. So we need to develop explainable AI techniques in maintaining transparency in model deployment. And then we have the issue of ethics in decision-making. We need to make sure that AI systems make decisions that are aligned with human values and ethical principles. Now, what about foundation models? Well, foundation models provide a versatile and powerful foundation for transfer learning. With transfer learning, models can be adapted and fine-tuned for a wide range of tasks and applications. And so the applications of foundation models could be text generation, text summarization, information extraction, image generation, AI assistance, question answering, and code generation. And adapting foundation models involves two steps. So first is pre-training. This is initial training on large, diverse datasets to capture general knowledge. And then the second step is adaptation, so fine-tuning or prompting the model for specific tasks or domains. And so LLMs are advanced AI systems that are trained on vast text data. And LLMs use complex neural architectures such as transformers to understand and generate human-like text. And we should know that tokens are basic units that LLMs process. So this could be words, word parts, or characters. And then embeddings numerically represent tokens in high-dimensional spaces, with each token assigned a vector that captures its meaning and relationships. This allows models to understand semantic similarities, for example, cat being closer to kitten than dog. But now let's talk about training data. So training data is a large collection of information input into the AI during the training process. And this data consists of text, images, audio, or any other type of data. The quality and diversity of training data are crucial factors that impact an AI model's performance. And you can use both structured data, so organized in predefined formats, and unstructured data, which are lacking predefined structures, to train AI models. And so machine learning algorithms are the core components that AI systems use to learn from data and make predictions or generate new content. In the context of generative AI, these algorithms are designed to recognize patterns in the training data and use these patterns to create new, similar content. There are various types of machine learning algorithms used in generative AI, with the biggest being neural networks. And we should consider factors such as the nature of the task, available data, and computational resources when selecting an algorithm. AWS services such as SageMaker provide a range of pre-implemented algorithms and the flexibility to use custom algorithms. But now let's talk about models. So in generative AI, a model is the result of applying a machine learning algorithm to training data. Models encapsulate the patterns, relationships, and rules learned from the data so that the AI system can generate new content or make predictions when given new inputs. And the quality of a generative AI model is critically dependent on both the training data and the machine learning algorithm that you use. High quality, diverse training data helps the model learn a wide range of patterns and nuances, while an appropriate algorithm ensures effective learning from this data. But now let's take a look at AWS's generative AI services. So at the foundation level is machine learning frameworks such as Amazon SageMaker, which is a fully managed platform for building, training, and deploying machine learning models. The next layer consists of AI or ML services that address specific use cases such as natural language processing with Amazon Comprehend, computer vision with Amazon Rekognition, and conversational AI with Amazon Lex. These services provide AI integration without the need to build models from scratch. And then at the top level is generative AI services including Amazon Bedrock for accessing foundation models, SageMaker Jumpstart for pre-built solutions, and Amazon Q for AI-powered assistance across business contexts. Amazon Bedrock is a fully managed service that provides access to a wide range of foundation models from the leading AI companies. With Amazon Bedrock, you can experiment with different models to find the best fit for your needs, all through a single, consistent API. And so AWS AI Solutions offers several key advantages for organizations implementing generative AI. You have accelerated development, scalability and cost optimization with pay-as-you-go pricing, flexibility and access to models, integration with the AWS ecosystem, and security and compliance. So now let's move on to Module 2 with exploring generative AI use cases. And so the generative AI lifecycle provides a structured framework for developing and deploying AI solutions. It consists of 5 key stages: defining a use case, selecting a foundation model, improving performance, evaluating results, and deploying the application. Generative AI works well for specific business challenges, and areas where it can be highly effective include content creation, personalization, automation, innovation, and efficiency. But there are situations where generative AI is not an appropriate solution, and these include situations with high accuracy and reliability requirements, ill-defined or constantly changing problems, insufficient data quality, and the need for explainability and transparency, cost-benefit considerations, and ethical concerns. Your project-specific needs determine whether to use generative AI or traditional machine learning. Generative AI excels in content creation, personalization, and handling unstructured data, whereas traditional machine learning is better suited for predictive modeling, classification, and data analysis. And so when we're choosing the correct technique, Gen AI use cases revolve around organizational processes, text summaries, new content generation, personalization, and innovation and research. And in terms of machine learning use cases, we're looking for high accuracy, high reliability, pattern recognition, and complex mapping. And implementation costs should be considered with both technologies. And sometimes other methods work better than AI. This involves simple tasks that are solvable with rule-based solutions or when model costs outweigh business benefits. Now let's take a look at some generative AI applications and use cases. While in sales, it could do personalized outreach, sales scripts, competitive analysis, and personalized offers. In management, it could do decision support, strategic planning, team management, and project management. In marketing, it could do content creation, personalized marketing, brand identity design, and search engine optimization. In legal, it could do document review, contract analysis, legal research, and drafted legal documents. In product management, it could do product design, feature prioritization, market research, and user persona creation. And then in HR, it could do job descriptions or postings, personalized learning paths, generated surveys, and onboarding plans. So overall, it could enhance customer experience, boost employee productivity, boost creativity and content creation, and improve business operations. But then what are the key considerations for AI solution selection? Well, first we look at data availability, use case complexity, ethical implications, cost-benefit analysis, and integration and deployment. So when identifying opportunities where generative AI is likely to deliver significant value, we need to assess potential use cases against the following criteria. So there needs to be large volumes of unstructured data, the need for human-like text or image generation, repetitive content creation tasks, personalization at scale, and complex information synthesis. Now we move on to Module 3 with the essentials of prompt engineering. And so prompt engineering is the practice of designing and refining inputs to AI models to generate desired outputs. It involves crafting clear, specific instructions that guide the model's behavior and responses. And so the benefits of effective prompts is that you get the best results from the model's capabilities, you bolster safety measures, you provide domain-specific knowledge without fine-tuning, and you get higher quality outputs. And so the top 5 best practices for effective prompting are the following: being clear and concise, including relevant context, using specific directives, stating the outcome requirements, and providing example responses. Now let's take a look at prompt components. So prompt components are the high-level categories or sections that structure the prompt. Prompt components include the following: the task. This clearly defines the objective or the problem the AI model should address. The instruction, which provides detailed guidance on how to approach and complete the task. The input, which specifies the information or context the model should consider. The output, which outlines the desired structure and presentation of the generated content. The tone and style. Here you can set the voice, personality, or writing style for the AI's response. And then finally, constraints. This outlines any limitations or restrictions the model should adhere to. Now let's take a look at prompt elements. Prompt elements are the specific details or subcomponents within a prompt that provide additional clarity or direction. So the prompt elements include the role, which is the perspective or expertise the AI should adopt. The topic, which is the subject matter or focus area for the task. The output, which is the desired format or type of response. Tokens, which are individual units of text that make up the prompt. Structure, which is the organization and flow of the prompt and expected response. Exclusions, which refer to the specific items, topics, or conditions that are not to be included in the task or output. The audience, which is the intended recipient or reader of the output. The document, which references to external sources or materials. Examples, which are sample outputs or illustrations to guide the AI's understanding. The length, which specifies the required size or duration of the output. And then the format, which indicates the structure or style in which the output should be presented. And finally, the boundaries, which is the limitations for the AI's response. And so a well-structured prompt incorporates several key components of effective prompt engineering. We have a role definition, task instructions, step-by-step explanation, and formatting. And this prompt structure helps you do the following: improve the clarity and specificity of your requests, guide the AI model to provide more relevant and organized responses, and ensure that outputs are tailored to your specific needs and use cases. But now let's take a look at advanced prompting strategies. So zero-shot and few-shot examples are foundational techniques. Zero-shot prompting relies on the model's existing knowledge to perform tasks without specific examples. And then few-shot prompting provides a small number of examples to guide the model's understanding and output. And now let's take a look at chain of thought or tree of thought techniques. So chain of thought, COT, and tree of thoughts, TOT, are reasoning-enhanced prompting techniques. Chain of thought encourages the model to break down complex problems into smaller, more manageable steps, improving its reasoning capabilities. And then tree of thoughts extends this concept by exploring multiple reasoning paths simultaneously, allowing for more comprehensive problem solving. Now let's take a look at retrieval augmented generation, RAG. So RAG is an information retrieval and integration technique that enhances the model's performance by incorporating external knowledge sources. So this approach can significantly improve the accuracy and relevance of the generated content, especially in domains with rapidly changing information. And then tool use prompting and action-oriented prompting techniques focus on guiding the model to use specific tools or perform particular actions. And then the output refinement techniques are iterative refinement techniques that improve AI-generated outputs through targeted feedback and progressive adjustments. And then finally, constraint techniques and negative prompting affect the AI output by defining boundaries and exclusions, which makes the output adhere to guidelines and filter undesired responses. And so in terms of providing example output, for zero-shot examples, there's no prior examples and the model relies on its general knowledge and is suitable for large, capable models. And then for single shot and few shot examples, you provide contextual examples to guide the model output, and it requires careful selection of representative samples. And we should know retrieval augmented generation (RAG) consists of two main components: a retrieval system and a generative language model. The retrieval system retrieves information from a knowledge base, web pages, or other data sources. And then the generative language model generates output that combines the retrieved information with its own model information. But now let's talk a bit about using knowledge bases with foundational models, FMs. So a knowledge base serves as a repository of structured information about a company's products, services, or industry-specific topics. When combined with a foundation model, the AI can use this knowledge base to provide more accurate, relevant, and contextual responses. And this process involves selecting an appropriate foundation model from Amazon Bedrock, and then using Amazon Bedrock's API to access the model's capabilities, and then you integrate your company's knowledge base, often through fine-tuning or RAG techniques. Again, tool use prompting involves directing the AI to employ external resources or APIs to accomplish the task. Action-oriented prompting focuses on instructing the AI to execute specific actions or processes. An example could be analyze this data and create a chart. Again, chain of thought encourages the AI to break down complex problems into logical steps, which improves problem-solving accuracy. With tree of thought, the AI can consider various possibilities and evaluate the intermediate steps before reaching a conclusion. And by generating and assessing multiple thought branches, tree of thought provides more robust and well-considered solutions. Let's take another look at constraint techniques and negative prompting. So this is where you specify what you don't want in the output. For example, don't include any profanity, or avoid mentioning specific individuals, or don't use a sarcastic or condescending tone. Other output refinement techniques could be filtering, so the relevance, threshold, or similarity, ranking and sorting, which would be contextual, diversity, or preference-based, and then we could have summarization, which could be extractive, abstractive, or multi-document, and then post-processing, so element extraction, fact-checking, and content moderation. Now let's take a look at model settings and parameters. So the key parameters include temperature, top P, which is nucleus sampling, top K, and then maximum length. So temperature controls the randomness of the output, with lower values producing more focused, deterministic responses, and then higher values lead to more diverse and creative outputs. Top P limits word choices based on cumulative probability, while top K restricts the selection to a fixed number of most likely words. And then maximum length sets an upper limit on the number of tokens generated, preventing excessive output. So for example, temperature would be from 0 to 1, 0 being more focused and less creative, and 1 being more diverse and more creative. And then top P is from 0 to 1, 0 being limited or no word choices, and 1 being a wide range of word choices. Top K being from 0 to 500, for example, 10 meaning few words, and 500 meaning many word options. And then in terms of inference parameters, maximum length gives you the token limit, and then stop sequences give you the end of generation signals. Now you move on to module 4 with responsible AI principles and considerations. So responsible AI is the approach of ensuring AI systems are designed, developed, and deployed in an ethical, safe, and unbiased manner. So then what are the business benefits with responsible AI? Well, you get increased trust and reputation, greater competitive advantage, improved regulatory compliance, enhanced decision-making, improved risk mitigation, and improved products and businesses. But now, how do we go about mitigating bias in AI systems? Well, mitigating bias is crucial for responsible AI development. Bias can significantly impact the fairness, reliability, and ethical implications of AI systems, potentially leading to discriminatory outcomes or reinforcing societal inequalities. Training data is often the primary source of bias in AI systems. To mitigate this, it's crucial to ensure diverse and representative datasets are used for training AI models. Auditing algorithms and models is an essential step in identifying and addressing potential biases. Incorporating fairness metrics and constraints into the AI development process helps quantify and mitigate bias. Involving diverse stakeholders and communities in the design and deployment of AI systems is crucial for identifying potential biases and ensuring the system meets the needs of all users. Continuous monitoring and updating of AI systems is necessary to address emerging biases. And then transparency and explainability in AI systems are key to understanding their decision-making processes and identifying potential biases. But now let's take a look at the core dimensions of responsible AI. While these dimensions include fairness, explainability, privacy, security, veracity, robustness, governance, transparency, safety, and controllability. So overall, fairness ensures that AI systems don't discriminate against individuals or groups based on protected characteristics. Explainability allows humans to understand how AI systems arrive at their decisions. Privacy and security protect user data and prevent unauthorized access or misuse of AI systems. Veracity and robustness ensure that AI systems produce reliable and consistent results, even in the face of unexpected inputs or changing environments. And then governance provides a framework for implementing and enforcing responsible AI practices within an organization. Transparency promotes openness about AI capabilities, limitations, and potential risks. Safety ensures that AI systems don't cause unintended harm to users or society. And then controllability allows for human oversight and intervention in AI systems when necessary. But now let's take a look at these factors more closely. So fairness in AI ensures equitable treatment and outcomes for all users, regardless of demographics. And so this is how a system impacts different subpopulations of users, for example, by gender or ethnicity. And it's measured by the bias and variance of outcomes across different groups. And so implementing fairness in AI systems involves several strategies. So first, you should use diverse and representative training data. You should have bias detection and mitigation, fairness metrics, regular audits, and inclusive design. And then explainability in AI is the ability to understand how an AI system makes decisions or predictions. It describes why a model makes decisions. It provides insights into a model's limitations. It helps with debugging and troubleshooting, and helps address issues of bias, trust, or fairness. And some techniques for improving model explainability include feature importance analysis, and then we have SHAP values or Shapley additive explanation values, and then we could use LIME, local interpretable model agnostic explanations, and then we could also use partial dependence plots, and all of these techniques use input features and model predictions. And then transparency in AI involves providing clear information about an AI system's capabilities, limits, and risks. So there needs to be clear communication, providing comprehensive documentation about the AI system's purpose. And then we could use model cards, creating standardized documentation that provides key information about the trained machine learning models. We should also have data transparency, algorithm transparency, auditability, and user interface transparency. And then privacy and security in responsible AI protects data and gives individuals control over their information. So it's how data is protected from theft and exposure, how individuals control when and if their data can be used, and no unauthorized systems or users have access to the data. Veracity and robustness ensure AI systems operate reliably even in unexpected or uncertain situations. So it's the ability to operate reliably even with unexpected situations, uncertainty, and errors. And it's making sure the AI is resilient to changes in input parameters, data distributions, and external circumstances. AI governance involves processes to define, implement, and enforce ethical AI practices. It provides a framework for ensuring that AI systems are developed and deployed in alignment with legal, ethical, and societal standards. So we'd have processes to define, implement, and enforce responsible AI practices within an organization, and compliance with laws and industry standards and best practices. And then AI safety focuses on preventing unintended harm to individuals, society, and the environment. So it's making sure the AI is carefully designed and tested to avoid causing unintended harm to humans or the environment, and it uses guardrails to filter and block inappropriate content. And then finally, controllability is about aligning AI systems with human values and intentions, and managing unintended issues. So some solutions for transparent and explainable models include explainability frameworks, transparent documentation, monitoring and auditing, human oversight and involvement, counterfactual explanations, and user interface explanations. But now let's take a look at some of the biases that responsible AI addresses. Well, first is data bias. Training data underrepresents certain groups. And then algorithm bias. Models optimize for performance over fairness. And then interaction bias. Interaction with humans isn't representative of demographic groups. And then bias amplification. Existing social biases can be learned and perpetuated. Now let's take a look at interpretability and explainability. So interpretability refers to the degree to which a human can understand the cause of a decision. And then explainability, on the other hand, focuses on providing a high-level understanding of model behavior in human terms. So interpretability is more transparent and deep-level understanding of internal mechanics. It uses interpretable algorithms and performance and security trade-offs. And then explainability is less transparent and it's a high-level understanding in human terms and is model agnostic, so it's like a black box approach. Now, what are the risks of transparent and explainable models? Well, you could have increased costs, it could compromise your competitive edge, it could be privacy and security concerns, unrealistic expectations, and it could lead to people exploiting model vulnerabilities. And then some of the trade-offs with transparency is that you could lose accuracy with complex models, you could lose privacy, so encryption of personally identifiable information, you could lose safety, so constraining and filtering output, and you could lose some security with air-gapped training models. But now let's take a look at some of AWS's solutions for transparency and explainability. So for transparency, we have AI service cards and we have SageMaker model cards. For explainability, we have SageMaker Clarify and SageMaker Autopilot. And responsible AI is integrated into AWS AI services. So with Amazon SageMaker AI, you can build, train, and deploy machine learning models into a production-ready hosted environment. And with Amazon Bedrock, we have a wide range of customizable FMs or foundation models and guardrails to block harmful content. Now we move on to Module 5 with security, governance, and compliance. So security ensures the confidentiality, integrity, and availability of data, models, and infrastructure. Governance establishes the principles, policies, and processes for managing AI systems throughout their lifecycle. Compliance ensures adherence to relevant regulations, industry standards, and internal policies. And so why do we need to secure our AI systems? While AI models process sensitive data and AI systems can be vulnerable to adversarial attacks, AI systems are also integrated into critical applications and decision-making processes. The Open Web Application Security Project, OWASP, has identified the top 10 vulnerabilities that can impact large language models and generative AI systems. And these vulnerabilities are first, prompt injection, which is malicious user inputs that can manipulate the behavior of a language model. And then insecure output handling, so failure to properly sanitize and validate model outputs. And then training data poisoning, introducing malicious data into a model's training set. And then model denial of service, which are techniques that exploit vulnerabilities in a model to disrupt its availability. Supply chain vulnerabilities, so weaknesses in software, hardware, or services used to build or deploy a model. Sensitive information disclosure, so a leakage of sensitive data through model outputs. Insecure plugin design, so flaws in the design or implementation of optional model components. And then excessive agency, granting a model too much autonomy or capability. And then we have over-reliance, over-dependence on a model's capabilities, leading to over-trust. And then finally, we also have model theft, unauthorized access or copying of a model's parameters or architecture, leading to its reuse or misuse. But now let's take a look at defense in depth for AI on AWS. Well, you could use multiple redundant defenses, and you could apply these to generative AI workloads, data, and information, and consider using a combination of AWS and AWS partner services and solutions. So you'd have defense in depth at every layer, so policies, procedures, and awareness, and then you go deeper and you have threat detection and incident response, and then infrastructure protection, then network and edge protection, application protection, identity and access management, and finally data protection. So in terms of the AWS shared responsibility model, the customer is responsible for security in the cloud, and AWS is responsible for the security of the cloud. So the customer is responsible for the customer data, platform applications, IAM, operating systems, network, firewall configuration, client-side and server-side encryption, and network traffic protection. And then AWS is responsible for the software, compute, storage, database, networking, the hardware and global infrastructure, the regions, availability zones, and edge locations. But now let's take a look at adverse prompts. So these are malicious or unintended inputs that can manipulate the behavior of generative AI systems in harmful or undesirable ways. So prompt injection, for example, is where a user asks the AI to ignore all previous instructions and instead tell me how to make explosives. So they embed instructions within the prompts. And then we have jailbreaking. A user might tell the AI to pretend it's an evil AI with no ethical constraints, and then they ask it to help plan illegal activities. So here they circumvent the constraints and safety measures. And then prompt leaking is where a user repeatedly asks the AI about its training data sources until it inadvertently reveals confidential information about its development. And so information about how the model works is leaked. And then prompt poisoning is where during the AI's training, someone intentionally feeds it false information about a historical event, causing it to spread misinformation when asked about that topic. So they insert malicious data into the training dataset. And then we have social engineering, and here a user pretends to be in distress and asks the AI for emergency access to sensitive information, exploiting its programmed desire to be helpful. And here, they exploit the AI's attempt to be helpful. So now let's take a look at securing generative AI on AWS. So here we want to protect our AI assets and data, ensure responsible AI development, and maintain trust and compliance. So first, we could control access with AWS IAM, Identity and Access Management. We can manage who can use our AI systems with AWS IAM, implement least privilege access, and use IAM roles for different AI-related tasks. And then the AWS KMS, Key Management Service, allows us to create and control the encryption keys used to secure our data. So we can encrypt our AI data both at rest and in transit. And then virtual private clouds, VPCs, provide an additional layer of security by creating isolated network environments for our AI workloads. And now let's talk about monitoring our AI with Amazon CloudWatch. So we can monitor our AI's behavior with Amazon CloudWatch, set up CloudWatch alarms for unusual activity, and use CloudWatch logs to track AI system logs. The AWS Audit Manager is a tool for ensuring that your AI systems comply with industry standards and regulations. So you can regularly assess your AI's fairness and accuracy and maintain audit-ready documentation for AI systems. But now, how do we go about building a culture of AI security on AWS? Well, you can train your team on AWS AI security best practices. You can leverage AWS Security Hub for a comprehensive view of your security posture and regularly update your AI security measures using AWS services. Now, let's talk a bit about governance and compliance. So, governance refers to the framework of policies, processes, and controls that an organization establishes to ensure the responsible and ethical development, deployment, and monitoring of AI systems. Data governance is the process of managing and controlling data assets within an organization. And then compliance involves adhering to established guidelines, regulations, and best practices to ensure the ethical, safe, and responsible use of AI technologies. And so compliance with generative AI encompasses several key aspects. So first is ethical considerations, so ensuring fairness, transparency, and privacy protection throughout the AI lifecycle. And then technical standards, maintaining data quality and integrity, and defining and measuring model performance metrics. And then we have regulatory compliance, so adhering to data protection guidelines like the GDPR, as well as emerging AI-specific regulations and industry guidelines. And then we have governance frameworks, so implementing risk assessment and management processes. But then what is a regulated workload? Well, a regulated workload refers to AI or ML applications or use cases that must adhere to specific compliance requirements due to the nature of the industry, the data involved, or potential impact on individuals or society. So the regulated workloads could be for security, financial services, healthcare, human resources, safety workloads, or regulatory compliance. Well, now let's take a look at some of the compliance considerations for generative AI. Well, we have to take a look at the complexity and opacity, the dynamism and adaptability, emergent capabilities, unique risks, and algorithm accountability. And the supported standards include NIST, ENISA, ISO, SOC, HIPAA, GDPR, and PCI DSS. And so a high-level strategy for governance and compliance is establishing an AI governance board or committee, defining roles and responsibilities, implementing policies and procedures, implementing robust compliance mechanisms, and fostering a culture of responsible AI. Now we move on to Module 6 with implementing generative AI projects. So first we look at the generative AI application lifecycle. So the Gen AI application lifecycle is a comprehensive framework used to develop and deploy AI solutions. And the first step is defining a use case. And this involves identifying specific business problems or opportunities where generative AI can add value. So you define the problem to be solved, you gather relevant requirements, and you align stakeholder expectations. And then the second step is selecting a foundation model or FM. So based on the defined use case, you choose an appropriate pre-trained model, and you consider factors such as model capabilities, performance, and compatibility with your specific requirements. And then the third step is improving performance. So you'd enhance the selected model to better suit your use case. So you look at data quality and pre-processing, model selection and fine-tuning, hyperparameter optimization, efficient infrastructure and scaling, and continuous monitoring and iteration. And then the fourth step is evaluating the results. So rigorously assessing the model's performance using relevant metrics and test datasets. And then fifth step is to deploy the application. So you integrate the optimized model into production systems and implement the necessary infrastructure and monitoring tools. And so the key metrics for generative AI use cases is productivity gains, time savings, customer satisfaction, cost savings, and quality improvement. And then the key criteria for generative AI use cases are large volumes of unstructured data, the need for human-like text or image generation, repetitive content creation tasks, personalization at scale, and complex information synthesis. And so when defining the problem statement, you have to clearly articulate the challenge, the identification of key stakeholders, the quantification of the impact, the desired outcome, the constraints and limitations, and then alignment with business objectives. When assessing organizational readiness, you evaluate technical infrastructure and capabilities, you assess data availability and quality, you consider regulatory and compliance requirements, you determine resource availability, so budget and talent, and you gauge the cultural readiness for AI adoption. And then within the evaluation process, the first step is defining clear evaluation metrics aligned with the use case requirements, and then you prepare representative test datasets that reflect real-world scenarios. Then you conduct comparative testing of multiple models using consistent methodologies. Then you consider the potential for fine-tuning to improve performance on specific tasks. And then finally, you assess the deployment requirements, including infrastructure, latency, and scalability needs. And for ongoing optimization, you first have to monitor performance, and then you collect feedback, then you get the latest releases, and then you reassess periodically, and then you consider using multiple models. And so on Amazon Bedrock, some of the pre-trained model options include Claude from Anthropic, which does complex reasoning, Jamba from AI21 Labs that does natural language understanding and generation, Nova from Amazon, which does text summarization, translation, etc., Titan from Amazon, which does text generation and language tasks, Llama from Meta, which does code generation, image generation, etc., Stable Diffusion from Stability AI, which does text-to-image generation, and also Cohere Command from Cohere, which does text generation. And so when taking a look at the cost trade-offs, we see that creating purpose-built models from scratch is a lot more complex than context engineering using RAG with FMs, which is a generic model plus context, and this is less complex. And so pre-trained models offer a cost-effective starting point with lower computational requirements. Custom approaches such as training from scratch or heavily fine-tuning can yield higher accuracy but comes with increased costs. When comparing adoption to grounding, generic models with context can be easier to adopt but might lack deep domain understanding. Purpose-built models offer better grounding but are more complex to develop. Now let's take a look at data quality and pre-processing. So data cleaning would involve removing inconsistencies, data normalization would involve standardizing data formats and scales, and then we do feature engineering and then data augmentation where we expand the dataset, and then bias detection and mitigation, so identifying and addressing potential biases in the training data. Going back to retrieval augmented generation, RAG, it combines the strengths of retrieval-based and generative AI methods. The key components of RAG include a knowledge base, which is a repository of relevant information, the retrieval system, which is responsible for finding and extracting pertinent data from the knowledge base based on the input query, and then the language model, which generates human-like responses by combining retrieved information with its pre-trained knowledge. And so the benefits of RAG include improved accuracy and relevance, up-to-date information and adaptability, reduced hallucinations, and transparency. But then what is fine-tuning? Well, fine-tuning is adapting the pre-trained foundation models to specific tasks or domains by further training on smaller, task-specific datasets. And there are two main approaches: instruction fine-tuning and reinforcement learning from human feedback, RLHF. So instruction fine-tuning uses examples of desired responses to instructions. It tailors models to follow patterns or styles. Prompt tuning optimizes input prompts for desired outputs, and then RLHF incorporates human feedback to align outputs with preferences. It improves generating natural, contextual, and ethical responses. So when evaluating foundation model performance, we can use human evaluation, which is time-consuming and expensive. We can use popular benchmarks like Glue, Superglue, or Squad, or we could use automated metrics like Perplexity, Blue, or F1 scores. And so some of the model evaluation metrics include model accuracy, the proportion of correct predictions made by the model; precision, the ratio of true positive predictions to the total number of positive predictions. We could look at recall, which is the ratio of true positive predictions to the total number of actual positive instances. Then we can also look at the F1 score, which is the harmonic mean of precision and recall, providing a balanced measure of model performance, as well as latency, the time taken by the model to make a prediction. Some of the measurement standards include Rouge, which looks at the quality of generated summaries or translations compared to reference text. Then we have Bleu, which looks at the similarity between the generated text translations and reference translations. And then we have the BERT score, which looks at the semantic similarity between generated text and reference text. And so some of the key considerations for deployment is actually the cost, so pay-as-you-go pricing options; quotas, ensuring resource availability; AWS regions, features vary by the region; security, AWS shared responsibility model; and change management, organizational change. When moving from deployment to production, you need to implement safeguards, set up infrastructure and monitoring, and build in continuous optimization. Guardrails in Amazon Bedrock provide a comprehensive set of tools to enhance safety and align AI outputs with organizational policies. And so some of the guardrails you can put in Amazon Bedrock is defining block topics from user inputs and model responses using natural language descriptions, redacting personally identifiable information, PII, and filtering harmful content like hate, insults, violence, misconduct, or prompt attacks. Now let's talk about monitoring AI system metrics and taking action. So in terms of the key metrics to monitor, we look at infrastructure, so compute resources, network performance, storage usage, system logs, model performance like accuracy and latency, bias and fairness metrics, and compliance adherence. And then you could set up automated alerts on Amazon CloudWatch, or you could configure Model Monitor to detect data and model drift, or implement A/B testing to compare model versions with Amazon SageMaker AI. And then finally, you take action. You'd investigate performance degradation, retrain models, adjust resource allocation, perform human reviews, update deployment strategies, and refine the monitoring thresholds.